Well, this isn't the best video recording you're ever going to see, but you said that wasn't important. So we're going to get on with it, and here we go. It's like deja vu, as a friend of mine said the other night. When almost every week it seemed like last summer, I read about or saw on TV a new news story about a school that had detected lead in their drinking water. I say deja vu because I spent a better part of the 80s and 90s cleaning up hazardous waste sites. First under Superfund, and then under the state acts that followed, which created a huge market for environmental consultants and emerging environmental technologies. What I didn't know was that several states, because of Flint, Michigan's water crisis, had taken it upon themselves to sample their schools' water for lead. Why? Because the EPA and 43 states do not require schools to sample their water for lead, if you can believe that.
An alarming number of Massachusetts schools have high levels of lead in the drinking water. Testing at over 1,000 schools last week found more than half had lead and copper rates above the, quote, action level. The State Department of Environmental Protection oversaw the testing. It was voluntary, and it didn't include every district in the state.
The results shocked everyone. 83% of the schools in New York City, 72% in Massachusetts, and 65% in Texas all had elevated levels of lead in their drinking water, prompting 20 states to propose legislation to require all schools to start sampling for lead in their drinking water. And surely, as more schools are uncovered with elevated levels of lead in their drinking water because of this effort, there will be increased scrutiny on daycares, hospitals, and other public buildings, creating a huge potential future market for any kind of emerging technologies for mitigation of lead in drinking water.
Of tests conducted by Metro Nashville schools, tests that discovered potentially dangerous levels of lead in some buildings.
Is there an established schedule of testing, or is it up to each district?
We do not have a standard.
David Money with the Tennessee Department of Environment and Conservation said the state has no idea how many school districts actually test for the toxic metal.
Schools faced with elevated levels of lead in their drinking water presently only have three options: bottled water, filters, and plumbing and fixture removal and replacement. None of these are very desirable. Great Water Tech saw this opportunity and licensed Fulmar Pipe Protection, a German-based technology presently in place in over 20% of Germany's drinking water infrastructure, that has been proven to mitigate lead in drinking water, but has yet to be deployed in the US. Fulmar Pipe Protection forms a micro-thin, flexible layer of silicate glass on the interior walls of piping and fixtures, stopping lead and copper from leaching. Our biggest challenge to date is that regulators and engineering firms in the US are not familiar with silicates as corrosion control, nor are they familiar with applying it at the building level. Corrosion control in the US is dominated by phosphates and is done at the water supply level. This can be changed 180 degrees by a few successful deployments here in the US, followed by a PR and marketing campaign to key influencers. This includes parents via parent-teacher associations, school boards, consulting engineering firms that are serving the schools, and school administrators. We consider this opportunity to be very similar to vapor extraction, which became the predominant technology for dealing with contaminated soil and leaking underground storage tanks, when EPA required that all underground storage tanks come out between 1985 and 1995. Vapor extraction was found to be more effective, more cost effective, and faster than excavation of contaminated soil and disposal off-site. and it became the predominant technology in that market when all those tanks were removed. And we think this has the same potential.